Hello, everyone, and welcome From the Field. From the Field is a New Zealand technical show where we bring the technical team from AWS here in New Zealand to share their experience and their findings in our market. And today we have a really special guest, James Turner. James, welcome to the show.
Hello, thank you for having me.
No problem. It's my pleasure. So, to everyone that is tuning in right now, James is a senior TEM at AWS. And before jumping on what is a TEM, let me just hand over to James to introduce himself and what is a TEM on AWS. James, over to you.
Hello, I'm a technical account manager based in Auckland. TAMs come from the Enterprise Support Organization. So if you have enterprise support with AWS, you'll have a TAM with you. We are very highly focused on our customers. We only have a small number of customers. We like to deep dive, get to know you very well, what your goals are. We try and prevent issues, but if there are issues, we're a link into the support organization that already knows who you are and how your systems work and what you're trying to do.
Yeah, it's like the Dr. Werner Vego says, right? Everything breaks all the time. So we need to have the support and we need to have all the help that we need when we need. So I think it's really cool to see that AWS supports our customers in that way. And I'm looking here on the screen. We do have Zen and Art of the Fargate. So what are you talking about today to us?
Well, I'd like to talk to everyone about um, when to use Fargate, how to use it, and sort of normalize the idea of Fargate, because I know to a lot of traditional infrastructure people, it seems a bit out there and scary to run their containers on something serverless. A lot of what the people we work with do, they do servers.
Hmm.
Um, and so to see something like this is a bit new and different. So what I hope to give people is sort of a sense of security and confidence when deploying something to Fargate.
Fantastic. So let's get started.
Fantastic. Well, the first thing we should talk about is running containers on AWS. Now, that's a big topic, but we'll just skim over it lightly. What is Fargate? Who's using Fargate? With a sort of focus on New Zealand. Then, if the demo gods take favor with me, we'll deploy
Fingers
a
crossed.
yeah, fingers crossed. We'll do a deployment of a Fargate service with CloudFormation. We'll inspect the containers, get into the containers on Fargate, and show you how to do that. And then we'll load test and performance test, and we'll see what breaks first. Is it my service or is it my laptop?
And all of that in one session.
All of that in one session. So a brief introduction to running containers on AWS. So there's two layers mostly, which is the container orchestrator and the compute platforms. So ECS is a fully managed service. It's the simplicity of cohesive services. And the Elastic Kubernetes service is fully managed upstream Kubernetes. It's easy to migrate Kubernetes apps with, you can use the same APIs and tooling, and take advantage of the vibrant Kubernetes ecosystem. So on this layer, we have the compute platform, and both of these container orchestrators support both AWS Fargate and EC2. Now, of course, there are tons of ways to run containers on AWS, everything from Beanstalk to Red Hat OpenShift on AWS. You can stand up clusters using KOps. Um,
You
even
name it,
for the
right?
yeah, you name it, you can do it. Now, so I thought we'd start off this with some container terminology, because I'm going to use these terms during the talk, and I think it's a good way to level set us. So a task that's the running instance of a task definition. So when somebody says this is my container, often they're talking about a task definition. Now that can be one or more containers. A service, now that's a set, or Kubernetes people will recognize that as a replica set. The service construct integrates with ALB and NLB, and it's the thing that maintains and runs copies of your containers. So if one container fails and it needs to kick it back into life, then the service is the thing that controls that. The service also wires up the load balancer. So the cluster on EKS, the cluster in the Kubernetes land, the cluster is a big, big thing.
Mhm.
In ECS land, it's simply a isolation boundary, and an IAM permissions boundary. So you don't have to create new clusters for everything, but you can create as many as you want. They are free. And then we have the orchestrator. Now that's the thing that tells which containers to run where and how. And the main ones, of course, are ECS and EKS. But this talk, I'll focus on ECS, but unless I state otherwise, most of the concepts apply to EKS as well.
And these names are interchangeable between EKS and ECS?
That's a good question. The task and service have different names. So an EKS person would, or an EKS admin would understand a task as a pod,
Okay.
and a service as a replica set.
Fantastic. Okay, so it's easy to change.
Yeah, yeah. But both of those concepts seem to work well in containers. So. Now, what is Fargate? So it's a serverless compute engine for containers. Now, that's very easy to say, but what does that actually mean? So it's where your containers run. It's managed by AWS, so it has, it's run by us. You don't actually have to know much about it to start using it. You just pay for what you use, and you build in 2 dimensions, CPU and memory. So when you want to run a task, you tell us how many CPU units you want and how much memory you want, and that's how it's built out.
So I
Now,
don't need to I don't need to choose my EC2 instance and type or family or anything else. Yeah.
no, nothing like that. The container just starts up. It's beautifully simplified. And it does have platform versions. So the latest is platform version 1.4. Now, these are very lightweight versions. They're a combination of kernel and container runtime versions. But if you're using 1.4, you won't suddenly have to upgrade to 1.5. If any security updates are needed, they're applied within the container versions, and new features are actually released within the container versions as well. So within the platform versions.
So does that mean Fargate will update my version automatically, or do I need to do anything to update it?
So when you deploy it, when you deploy a Fargate service or a Fargate task, you do tell it what platform version you want it to run on. There are times when, for example, if the underlying instances that are powering your containers, if they have an issue, we will sometimes tell you that or warn you that those tasks
Mhm.
are going to be replaced. Now, 99%
Ah,
of the time, they'll just get replaced. And if it's part of the service will start up another container and it will be okay. You may want to also force your own deployment so you can control when the tasks are replaced. But also, you may just do a normal day-to-day deployment, and the tasks will just roll and get updated as well. That's more for long-running tasks and services.
fantastic. So that reduced my maintainability on operations around how and when to update, right?
Yeah, that's exactly right. As it's a managed service, you don't have to worry about applying operating system
Cool.
updates. So this is probably the most common question I get asked about Fargate is, am I sharing services with anybody else? And the
Mm,
answer to that is no. So it's completely managed
yeah.
isolation and quarantine. Um, Tasks have isolated compute resources. Nothing is shared with other customers. Um, the current generation of Fargate is Firecracker micro VMs that run on bare metal instances. Before we did that, we ran on single tenant EC2 instances. And Fargate for a long time has been doing tens of millions of launches a week. And as you can imagine, that's quite a lot of work on the control plane.
Absolutely. Every day we see more and more customers onboarding on Fargate. So that's it's beautiful to see that everything is isolated.
Yeah, and so Firecracker, this is something that you may not have heard of. It was
Mm.
written in Rust in 2017. Just that you don't have to know any of this to run on Fargate, but I find it really interesting, so I thought I'd go through it a bit.
Yeah,
Um,
I love to know what's happening behind the product. So please go for it.
um, and it's an open source virtual machine manager. It was published by us. That uses Linux KVM. Now, it does have some limitations. So, for example, we can only boot relatively recent Linux kernels, and only when they're compiled with a specific set of configuration options. And there are over 1,000 compile options. So, it's very strict in what it can run. There's also no support for graphics accelerators, no hardware pass through, and no support for most legacy devices. There's no emulated BIOS, and it's not a complete device model. So the only devices it supports are a network device and a block device, and we give it a one-button keyboard. So why do we do that? Well, first of all,
Why?
so first of all, there's less than 5 meg memory overhead per VM. So that's why we call them micro VMs.
Mm,
It gives us an incredibly fast startup time. So on an i3 in Metal, it's less than 125 milliseconds.
mm.
And the main thing here is not only simplicity, but also a reduced attack surface. So um, there, when you can do very few things, there are very few ways to very few attack vectors.
So that's from so the why behind that is from a security perspective and also on a performance perspective, because we reduce the blast radius of what you can do and how you can change something, and also to speed up the generation of that specific VM. That assumption is correct?
Yeah, that's right. It's mostly to do with reducing the heavyweight usage of the single tenant EC2 instances. So rather than using the EC2 control plane to do all this work, we sort of had to build something that was more fit for purpose for containers. And it is something that's well proven and tested as well. This is technology that powers Lambda, for example.
All right.
So,
Okay.
um, so network isolation. So a task has a dedicated ENI, or a pod has a dedicated ENI, Elastic Network Interface. It does require you to change to AWS VPC mode if you've got, if you're migrating from EC2. But that interface is in your VPC. It's got your security group on it. So it can be used to download, so it can be used to pull container images. So if you have a repository on-prem that's on the other side of a VPN or direct connect, then that will work nicely through private connections. It's how log streaming works. It's how it gets access to its secrets. And it does provide a security group per task, which is very
Mm.
useful. And you'd also get a 20 gig ephemeral storage, dedicated storage that is encrypted. So tasks get an isolated storage block. Now, if you've got two containers in the task, they can both write to the ephemeral storage area. That seems to be, but it is very ephemeral. That
Mhm.
use case seems to be mostly around, for example, if you have an Nginx container fronting a backend container and you do a pipe between the two of them.
Makes sense. Yeah. And I don't need to configure the storage up front, right? That will be part of my container when my service in this case and task when I define the service, right?
Yeah, that's correct.
Cool.
Now, so how's Fargate used in New Zealand? We're a New Zealand technical team, so we thought we'd talk around how, in generic terms, how it's used here. So we run the full gamut of from innovation teams. The direct quote from one of my customers was, "It does just work," and they were
That's
able to.
beautiful to hear.
And that was a great story. They had a very complex AMI build pipeline, and they were spending more time running instances than they were actually being an innovation team. So they rebuilt their entire container stack in quite a few hours. I chat to them on Friday afternoon, and he sent me a message on Saturday morning um, saying he'd done it. And it allowed them to focus on their product. So just anecdotally, we went from talking about containers basically every day to talking about everything else but containers.
Wow.
Now, which is amazing. Now, enterprises who want a hands-off approach. So I was um, talking to a New Zealand enterprise. A new team had been given given responsibility for a legacy ECS stack. They needed to roll the AMIs relatively urgently to update them. Now their interest in Fargate is saying, well, we don't really change this. This isn't, rolling these AMIs doesn't do anything for us or our customers. Have controlling the AMIs and the instances doesn't do anything for them. So they just want to put it on Fargate and then forget about it.
Up and running as fast as they can.
Yeah, that's right. They'd sort of had this product hoisted on them, and they were kind of wanted to forget about it as soon as they could. uh, Another enterprise gave us feedback that it was beyond lift and shift, so that they
Mm.
could modernize on the way through. Their interests were cost saving and operational efficiency. Again, their teams focused on cloud. They didn't want to be Linux admins anymore. They just wanted to run the containers as they could. And independent software vendors is what ISVs stand for. So if you think of software as a service vendors, they like the fact that it scales to very high levels. So I've just helped out with a proof of concept that the customer was looking at doing, where they needed to spin up hundreds of containers at a time to do small discrete bits of work and then dump them out. And the
It,
alternative, sorry, Gary.
no, go for it.
The alternative to that is they spin up hundreds of EC2 instances and then run containers on them, which is just a more complex workflow.
But it still works, right?
Yeah. It does work,
It's
yeah.
good. It's good to see that the underlying technology, which is container, it helps teams across different segments to innovate on AWS. And I think there's a really good way on AWS, as we saw before, to run containers. And Fargate is one of the top three for sure, based on everything that I have seen so far.
Yeah, my understanding is that 40% of all new container workloads are Fargate, and that
Wow,
figure may be out of date.
that's a great number. Holy cow!
So it's actually from being a an innovative and exciting approach, it's actually now becoming the new normal.
The new normal. I like that. I will use that.
And it does the heavy lifting for us. This is why we want to use Fargate. So I asked some of my colleagues what they'd seen and why their customers like to use it. So you have to create and maintain AMIs and the pipelines to build them. You need to update your OS and packages on the OS. Some of my customers have to install monitoring agents. They have to install and configure security agents. There are custom IP tables rules to prevent access to metadata and other things. You have to scale the underlying compute to match the container workload. So if you have a task that needs to auto scale up, so it adds a few more tasks, you also need the underlying instances to be there to run them. And you'll see this in EKS as well, in Kubernetes, where you have the horizontal pod autoscaler, which then interacts with the cluster autoscaler. So you've got the sort of Rube Goldberg machine that
From
this
top,
triggers
yeah.
this, triggers this.
That workflow of triggerings, yeah.
Yeah. You also have to get the most out of your instances, you have to what we call bin pack them, or play container Tetris, where this container and this container can sit on this type of instance, and that actually gets to be quite a lot of work. Not to mention the other things that you see on here, including instance access, connecting storage, and gracefully draining the instances when you want to remove them. We also had stories of copying and pasting random and sketchy Stack Overflow stuff into the hosts and then forgetting about it. We have teams that build their own container images on different OSs because they know it and they spend a lot of time doing that. Yeah.
That's just a few of the benefits of using Fargate, right? I think we are just highlighting here some of the experience that we see with the New Zealand customers, but it's not limited to this list for sure.
No, in running it, sometimes you do need to run EC2 instances, but if you're running instances in any way, and if you're a responsible organization and you're keeping up security and patching and stuff like that, it's important to highlight there's a lot of work to do. And this slide is probably more influenced by my view of customers' operations.
Yep.
This is the thing that they're doing day to day, day in and day out. They're updating instances and doing stuff overnight, not to interrupt their customers. So it's important to consider.
Absolutely. I think this is one of the advantages of bringing these learnings from the field, so then we can share with the wider public here who is watching, and to avoid that and see what are the gotchas. So when to choose a C2 launch type. So what is it?
So sometimes you do need to run the containers on EC2. So I would say I tried to go for all G's here. I don't know if this looks too forced, but Graviton.
Why not? Yeah.
Yeah. Fargate runs on x86 compute at the moment. We're seeing really exciting uptake in Graviton, but Fargate is at the moment x86. graphics. So we don't provide access to a graphics card in Fargate. ECS supports graphics quite well, and we do have customers using graphics very effectively, both for literal graphics workloads and machine learning and stuff like that. So some of those workloads require an EC2 instance. I say giant instances here. We support currently 4 vCPUs and 30 gig of memory. And if you need more local storage than 20 gig, then you'll need to use EC2. It's not to say that you can't connect, permanent storage to Fargate, but if you need that super fast
Ephemeral.
ephemeral
Yeah.
storage, and then general stuff. So if you need privileged containers, then you'll need to use EC2. Generally, you don't need the privileged containers. They tend to be, security auditors and stuff like that.
Hmm.
Certain kernel capabilities. If you need to mount volumes from the underlying host, then you'll need to use EC2 because you'll need to give it some volumes to mount. If you want to map host ports directly, then you'll need to use EC2. And if you want to run Windows containers, you'll also need to use EC2.
And all of that is good to plan up front, right, James? So when I'm thinking about migrating to the cloud or migrating to a Fargate, there's any kind of a checklist or best practices that I need to pay attention besides that?
Yeah, there is. So this is these are very generic advice of where Fargate is an anti-pattern or is
Yep.
contraindicated for it. So I think one of the best things you can do is talk to your friendly TAM or solutions architect, and we can help you do the right thing. But when you start off, if you're planning to run everything serverless, just be aware that there are going to be really good use cases to run EC2, and it's not uncommon to see these applications run on EC2 and these applications run on Fargate.
Fantastic.
All right, so one of the my favorite things about Fargate is how well integrated it is with AWS services. So we'll do a deployment of a Fargate service. We'll go through what it is, but while it's deploying, I'll tell you what we're doing. But there are lots of ways to deploy Fargate containers. You don't have to do it with CloudFormation. Terraform is very well used here. Of course, then you go into AWS App Runner, ECS Copilot, the AWS CLI.
Every month a new tool.
Yeah, if you
No,
can
but
name it, that's
yeah, but I think that just show how much AWS invests on developer tools, and we enable our customers to use multiple ways and fit to their own software lifecycle.
yeah, and it means that no matter what you're used to doing currently, you can generally do it on AWS. Now, just a note for those of you who are looking at doing CloudFormation or are um, wanting to know some best practices, this is actually providing the container repository is actually not a best practice as a default in the parameter, because if you wanted to change that, then it's more difficult too. But for a demo purpose, it means the CLI is a bit simpler. But if you're going into production, don't do this, and don't put latest in here either. Give it a version. So my service, I will deploy from the CLI. I like to use the CLI because this way is very portable onto build agents. So when you start to automate your pipeline, you might want the build pipeline to actually run a CLI command to do the deploy.
And in this case, the credentials are coming from your environment, right?
That's right, yeah. So the credentials come from my environment. And in the stack, now we could go from a completely blank account to a multiple service with VPCs and everything we need in just one command. In the interest of time and sort of splitting up my various demonstrations, I've already got a VPC created. So we just hook into the VPC that's already created. And you can see that the create's in progress. So what is it that we're actually creating? So in a very basic sense, this is a pretty standard web service. We've got an internet-facing application load balancer. We've got Fargate tasks with private elastic network interfaces. So they're wired up into my private subnets with the ALB knowing where to send traffic. We've got two built-in scaling definitions defined here. We're target tracking CPU and we're target tracking memory. I do have target tracking ALB requests per target. Now, this is a really interesting way of scaling. If you know how many requests per target you can have, you don't have to worry about a trailing metric like CPU or memory. You can be very proactive and just track ALB requests per target. Now, what this actually is, it's a Python Flask app. It calculates pi to however many digits you give it. So we will run a locust load test, and we will be asking for a certain number of digits. From memory, it's about 2,000 digits, and we'll simulate a rising number of users. Now, as we can see in the configuration itself, we will go to approximately 500 containers. So we'll start off with three tasks or three pods if you're from the UKS world, and we'll go up to about 500. Now we'll see if we can make that number today. I'm not convinced my MacBook's going to get us there.
That's what I call auto scaling.
Yeah, that's exactly right, and it will go down. The number will go down once we're finished as well. But of course, with application auto scaling, it scales very aggressively to start up with, and then it goes down very slowly, and that's by design. Now, these numbers are not particularly realistic for a production application. I'm targeting quite a low average CPU because, in the interest of time for a demo, we want this thing to scale aggressively, right? We really want to put our foot on the gas and get this thing going. So we've got a scale in cooldown of 30 seconds and a scale out cooldown of about 10 seconds. And in CloudFormation, this is all you need to do to define a scaling policy that gets you CPU target tracking. Commented out here, I have the requests per target. Now, the reason I've commented it out is because it works too well. Right? We want to see stuff break. We want to see errors. We want to see Fargate recover from the errors. We want to have see if we can give ourselves a really bad client experience while watching the service catch up to itself and get the service back. All right, so what's different? Now, this is for if you have an existing deployment on EC2 and you want to move to Fargate. So obviously you need to tell it that it's a Fargate service. So you need to add a launch type.
It is in the name, right?
Yeah, that's right. And you need to give it CPU and memory values. These are optional on EC2 deployments, but they are critical on Fargate because we need to know how to provision the underlying resources. You need a task role if you don't already have one. You can have no task role, but if you, for example, if you talk to S3 or drop things onto SQS, you'll need a task role to do that. And you need to change to AWS VPC mode for networking.
Cool. Yeah, on the task row thing, I do remember there's a difference between the task row on the EC2 type and the task row on the Fargate type. What is the main difference here?
So the task role, there's two here named very clearly, the task execution role and the task role. So the way to think about these is the task execution role is what privileges do we need to execute the task? And the task role is what does the task need to do? So for example, you might have if you talk to an S3 bucket, you need a task role. Now, in some ECS deployments, that's given to the container by the EC2 instance underneath it, which is not an ideal situation to be in because then if your tasks can access the instances role itself, it'll have different privileges than the tasks need. So for example, one might need to talk to SQS, another might need to talk to S3, and a third one might need to talk to neither of them, but they will get all of the permissions. So
permission, yeah. So on that Fargate is already helping you doing least secured privilege, right?
That's exactly right. It's helped you explicitly state what permissions your service needs.
Cool.
Cool. All right. Shall we see if this has worked?
Oh yeah, I'm excited. Let's see it.
Fantastic. So we have in our stress test task, um, we have an output, and that's a load balancer. And welcome to our stress testing container. And we'll do /pi/ let's do 200 digits. And we get the value of pi, and let's do a few more zeros, and we time out, which is good because it takes us so long. We don't want it to sit there waiting. So let's have a look at our services. So we want to have a look at Elastic Container Service. And this is our nicely named service that CloudFormation has created. So here we go. We've got one service, we've got 3 running tasks, and we've got nothing pending. We've got nothing running on EC2, and we've got nothing in ECS anywhere. So we'll have a look at the cluster and see what we can see. So in our service, which is in Fargate, this is the part we're really interested in, less so the cluster. We've got all the details of it. We've got the details of the tasks that are currently running. You can also have a look in tasks that are stopped to see why the containers won't run. What's happened on our service. So we've reached a steady state. We've registered targets because this is brand new. We've got our auto scaling configuration. Where here you see we've got a minimum of 3 and a maximum of 500. Now we're also starting to see our metrics for our service. So we can see the CPU utilization across the whole service. And remember, this is across the service, not the cluster. And we also get logs, helpfully in the same interface, which is always a nice experience to use, right? Because you can just stay in the one place for to get basically everything you need to know to help diagnose the task. So one thing we will do is we'll drop into one of these containers, and we'll have a little bit of a poke around using ECS exec. So traditionally, you would SSH into a jump host, or you connect to your VPN, SSH into a jump host, and then jump into a container instance and Docker exec into a task. We're going to create a command. Now we will create the command, copy and paste it, just because it's easier. Because there are a few things we need to copy and paste into the task itself. So we're going to use ECS execute command. We need to give it the cluster that it needs to connect to. We need to give it the task. And we give it the container. Remember, tasks can have one or more containers in them, so we need to tell it which container we want to get into. In my case, I only have one container. This is an Alpine Linux container, so we don't have bash, so I'm going to give it sh and interactive. And we're into our container. And so from here, so this is a traditional DevOps role, is where you'd find a container that's having a problem, an example of a container that's having a problem, and you get into it. Now, this is all done with IAM, so your developers can have the right permissions to do this, and they don't have to have SSH keys or anything floating around anywhere.
And no jump box based on host anymore. So
no VPN, no nothing like that. Straight into it. Through an Alpine Linux, and of course the classic thing when you're doing Docker is that you have a look at what the underlying host is running, and it is Amazon Linux 2, of course. So this is us inside our container. Now there's probably not too much to show because this is such a simple container. We can have a look at df-h, and we can see we've got a 20 gig ephemeral storage area. We can have a look around in top, and we can see what's going on.
So
and that's
you
us.
did mention in the beginning that this is the common workflow for operations person or even a developer. So what are the main points or the main key phases that someone should SSH or interact with the contain with the task itself directly without looking towards the cloud formation or AWS CDK? What are the main key points that if I need to I need to connect to the task? What are the common cases here?
Well, there's two schools of thought here,
Mm.
depending on which school of DevOps you come from. The first school of thought says your logging needs to be good enough that you should not get into the container, and in fact, we will not provide access to the container through any methodology, because if a specific container is having a problem, you just stop the container and a new one spins up in its place, and it's all happy. But what I find, and even when I've been in this situation, is sometimes you do actually need to get into a container. Maybe you want to do in Python, you might want to run PDB to debug calls that are going through the system. Now, whether or not you want to do that in production is totally another story, but there are all sorts of little tools, commands you can run that necessitate getting into a container. And it's just a really nice escape hatch to have that may get you out of a bind during an outage or during an incident.
Yeah,
Um,
absolutely. I think we definitely need a different talk just to talk about that.
oh, exactly. And whether or not this is the 12-factor app. But yes, there are a couple of reasons, and I know some people, to get an understanding of how their systems are working, they just like to come in here and just have a look at what's actually in the container
Yep.
and see how the service is laid out. It helps them understand how to troubleshoot it.
It's good to have the option, right?
Oh, exactly. It's good to have it and not need it than to need it and not have
Beautiful.
it. So that's ECS exec. Now let's try a load test. So for this load
Yeah.
test, we're going to try and break things. Hopefully not the string. Hopefully that keeps on running. um, but to do our load test, we're going to run something called Locust. So I'll just fire up Locust. And we're mostly using it because it's easy to use. It has a nice GUI. So let's try, we'll go to 2,000 users. We'll spawn, let's call it 15 users a second, and we'll go back into CloudFormation and we'll get our load balancer. And we'll fire this up. And so we're going to spawn 15 new users a second. And let's have a look at our charts. These are our requests per second and our response times. Now, the idea with this load test is it's putting enough load on the system that it will actually get to a point where things start falling over. So CPU will get to 100%, the tasks will stop responding in time, and the load balance will shut them off. But we'll also see how we accelerate our way out of this. Now, remember, one of the things with this demo is that it requires a few minutes to get an average of a high CPU utilization, which is one of the reasons I've set it so low. So you might find yourself in a situation where you've got a marketing release that's been done and you actually are expecting an enormous ramp up. So you might say, actually, I'm going to target a lower CPU utilization for the duration of this launch, just because I want it to react quickly. And you're starting to see these response times come up here as well, which is good. So our number of users is increasing linearly. We've got our response time coming up because we're starting to load this thing up. And our requests per second are starting to level off.
That's a huge
So let's,
spike.
yeah. And remember, we started from 3 little containers, so we've got
Yep.
to have a look at what is going on in our cluster. So remember, we go to our tasks. So we haven't managed to break any of them just yet. We can have a look at our events here. Now, this is something that you can use operationally to alert on. So you can take these through EventBridge and go to PagerDuty, for example.
Mhm.
Cool. And so now let's have a look at our metrics. So immediately you can see our maximum CPU has gone straight through the roof. But our average is taking a little while to get there. Our memory, of course, this is not a memory intensive operation, so our memory throughout this whole demo will just stay pretty low. I like to put the memory auto scaling piece in there just to show people that it's easy if they want to do it.
Yeah, you can target many metrics if you want to do outscaling. It's not limited to CPU or memory, so that's good.
Yeah. And you can see here we've actually stopped. We've found a task that's unhealthy because its load has brought it down. As happens to any application if you load it out. We've deregistered it, we've stopped it, and we've started a task. So what does that look like for the user experience? So at the moment, the user experience is still a little bit average. Our response times are going up. Our requests per second have kind of gone down a little bit. You can see it's gone down with the removal of that one container, but the number of users is still piling on. So if you're running a service that is going to get an immediate massive load spike, part of the art of auto scaling is to be able to prepare for that.
Yep. And it's a common question to how I can outscale instantly, right? So like under a minute.
Yeah. Now, if this was organized within a company I was working for, obviously you'd be planning for this and you'd be saying, well, on the morning of the marketing launch, we're going to up our base container numbers and maybe bring the CPU utilization down a little bit, just so that you can be really prepared to ramp up. You might even say, well, maybe I'll just turn the dial up to 500 and ride this one out. But we want to make the most of our infrastructure and most of auto scaling. So we'll see where we get to here. And so you can see it started 2 tasks. It's had to stop 2 tasks. And now our service is reaching a steady state again. So the wheels are starting to fall off our poor little Python service.
It's reaching its limits.
It's reaching its poor little limits. My laptop is reaching its limits.
Can fry an egg on that.
Yeah. And so we're seeing most of these are requests that are working, but we're now seeing requests that are failing. So of all our requests, we're starting to see higher failure numbers here. But we will very soon see the impact of the auto scaling kicking in.
And there's any recommendation or maybe common practices around what kind of alerts we should have on these scenarios?
Yes, there is. So you can the auto scaling itself is an alert. You may be wanting to look for things that are not just the containers. So, for example, load on the database. So we're going to bring this from 3 tasks to 500. Now, most services aren't a little thing that calculates pi. Most of them have dependencies downstream. Very common to see 1 or 2 databases in the mix. These downstream services may be owned by other teams. Maybe it's down the other end of a direct connect in a data center. So Fargate now has said, well, I'm going to launch 7 tasks, and it has successfully done so. But in your data center, you might not have these, you might not be able to scale to meet it. So you may find that your VPN connection gets saturated. Maybe something that you don't control is an issue. So you have to look for when your application is telling you that. So if you're getting, for example, 500 errors from another REST service, that may be something you want to look at in your logs. You also want to be aware of when you're scaling. So it may be perfectly normal for you to go from 3 to 7 tasks in the morning, right? So that may be just business as usual, but maybe 100 tasks is something where you want to go, hey,
What's happening there?
what's happening here? Yeah. And you can see our response times going up and down as we launch these containers. We're at, say, 5,000 users. And for the rest of this, we just kind of need to start watching auto scaling do its thing. So message successfully set desired count for 12. So we went from
Wow.
3 to plus 5. Now we're going to 12, and we're
Four
going to see the
times
impact of
the
that.
base value.
Yeah. So we've got pending tasks at 5. So that means basically we're waiting for them to be allocated compute, and then they need to be pulled. Now, one thing I would advise here is that your repository is now a tier 1 service for you. If your repository goes away during this event, you cannot scale.
That's
So
another good point too. Yeah.
yeah, so if you've got if you're running a private repository, it's worth making sure that that is highly available during one of these one of these events. For example, you know you're going to scale, you would want to make sure that it's in good condition, that you're not doing any work to it, anything like that. Now, this just for my demonstration, I'm just using ECR because it's a nice, easy service and works quite nicely here. But you know, a lot of our customers want to use different repositories, and Fargate is actually not opinionated about which
Okay.
repositories you choose. Yeah.
There's any way to cache the image that is pulling?
Unfortunately, not. You just need it closer to the Fargate ENI. So
Okay.
if you had if you're running a say JFrog Artifactory on premise, you might want to also have it on an EC2 instance in the cloud for cloud usage, just so you're not going over that VPN or that direct connect.
Yeah.
Now you're seeing here Fargate also trying to maintain the service under this event. You can see every so often the pending count goes up when the desired count hasn't changed. And that's because containers are unhealthy and they're being removed and replaced. So throughout this whole event, we're getting the service is trying to keep itself healthy and let itself grow. And you're seeing the response times be affected by this as well. So the median response time has gone back down as it carries on, and hopefully we'll see lower failures. And let's have a look at our metrics. So these are just these are CloudWatch metrics built in. One of the reasons I like this console view is that everything to do with my cluster is just in one place. So I can look at my logs and my metrics just by tabs on the same user interface. Now
Out
for
of the
us here,
box.
yeah, straight out of the box. You can use FileEns to send the logs anywhere you like. You can also use CloudWatch logs and have various collectors off the back of them. You know, there's many ways to do this, but one of the cool things about Fargate is how it manages getting your logs out of the system. So let's have a look at our events again. I can see our desired count is growing. We've started 8 tasks, and we've set our desired count to 21. And our failure rate is starting to go down. Our response time has started to go down. So our user experience has kind of come back to where it needed to be.
After a long time, right?
Yeah, after a long time. So, so this is a bit of one of the reasons I like to actually break in this demo, because of course it would be nice to
Mhm.
show this working perfectly and the tasks just scaling as they should. But in the real world, these scenarios happen where, for example, this could actually not be a marketing launch. This might be us responding to a DDoS.
Good point. Yep.
So while our tasks are growing and we will eventually service the DDoS and write it out, we need to sort of also think about other ways of sorting that out. You know, if the one thing that would cut me off is because I'm coming from one IP address is if we had a WAF rule, which limited the requests that I'm allowed to make. That would stop me in my tracks.
Right on the edge, right?
Yeah, that's right. Luckily, this is my service I'm breaking, and I haven't cut myself off. So this service is going to start growing because we want to add more and more users. And we'll be able to do that once the requests per second sort of settle down. We've got 33 tasks now. So you can see we're starting to grow. ECS is getting quite aggressive and saying, okay, those small amounts haven't worked, haven't solved the problem just yet. I need to start throwing some actual, I'm going to need to start throwing some resource at this. So we've started 12 tasks. And again, we go through the Fargate or the ECS flow, where we've got tasks that are created, but they're provisioning, and we want them to be running. Now, this also we're starting to have a look at where we've got stop tasks. Now, these tasks have failed, but we know in this scenario why they've failed, because the ELB health check has decided it's not healthy. But this is also a really useful view in ECS to just, no matter how you're doing ECS, to have a look at why your tasks aren't failing. So, for example, a really common thing is when you've got a repository authentication error and these tasks have stopped because it could not pull container. You can have a look at there. You can easily solve those errors.
Are these logs sent to CloudWatch too, or not?
Not these ones. These are ECS events. You can get them through EventBridge. All right. So in another very short while, as our workload increases, so we're at 5,000 users. Our failure rate's going down, our response time's gone down.
Everything's going back to normal.
And everything's going back to normal. But Fargate's still not happy about this because it's still, our metrics will still be saying, well, we haven't quite got to where we need to be yet, but our metrics are going down. So now it's a race between Fargate and my laptop.
I do bet the cloud has more resource, right?
Yes, that's right.
And speaking of load testing, there's any other tools that we could integrate that via our CI/CD platform, or anything that you would recommend to your viewers?
I like Locust because it can be run from the command line. It's written in Python and does produce nice reports about how a load test went. So if you are going to run a load test in your CI/CD environment, Locust is a good one. The classic one is JMeter as well, and JMeter works just fine too. The area you want to, one thing you want to make sure with your load testing is, again, as you say, the cloud has got more resources than my laptop could ever do. So you also want to look at running distributed load tests. Rather than using just one machine, you need to be really, if you're going to do this at any scale, you need to be deploying it across multiple machines and attacking the service that way. All right, and we seem to actually have done it with, say, 30-something containers. So we've outscaled my laptop pretty quickly. So, but I want to see 500 containers. I want to see something break here. So let's go to number of users, 20,000, and let's start 30 per second.
Let's hope your MacBook don't crash.
I can already feel it starting to buckle under the load a little bit here. I mean, this may be all she's got.
Fair point.
Let's start a new test. We want to go 200 users per second. We'll get there straight away. But yes, this is, I mean, almost an unsuccessful load test demonstration because we didn't get the number of containers we wanted. But on the other hand, it's Fargate successfully scaled itself out of a slightly unrealistic test.
Which also proves a point, right? We do have a solid platform to help you out scale your application, which is pretty good.
Yeah. I mean, it's pretty good that an artificial test, it's we're able to get to scale out. It, it does show us that when we want to auto scale or when we want to test auto scaling, distributed scaling is a big component of this. In fact, recently we released an AWS solution for running auto scaling on, um, for running a distributed load test on. So I will stop this test and we'll get the metrics out of our test. So if you're running the locus by the command line, one of the really nice things about it is you, even if you're not using the nice graphical user interface, you get the results down here. So you can easily process these and uh, see if they've gotten better or worse since your last deployment, if you're running them as part of a CI/CD system. And with that, thank you very much for attending the talk.
Fantastic, James. Thank you for this overview of Fargate and seeing that in action. That was great. And we saw the platform can auto scale, and we saw Loctus how we can run load testing. So, besides that part, from all your experience helping customers using AWS Fargate, what could be one or two tips that we may have for people to follow up from here?
My first tip is just because it's new, don't be scared of Fargate. It's a solid platform to run on, and it will make your life easier, your day-to-day experience easier. My other piece of advice is it's not for everything. So there are scenarios where you will need to run things on ECS or on EC2 instances, and they can be done well as well, including taking some of the learnings from Fargate. So, for example, using the AWS VPC mode can be used on EC2 instances. Um,
That's
and of
great. Yeah,
course,
need to plan ahead, right?
yeah, that's exactly right. It's too easy to say do one way or the other, but I do hope that you get a little bit of an understanding of what it's like to operate Fargate, troubleshoot it, auto scale it, and yeah, live day to day with it.
Yeah, that's beautiful. So if anyone have any questions, please reach out to us via YouTube or here on Twitch and follow us on LinkedIn too. So thank you for your time today. Thank James for coming to the show and see
Thank
you
you very
next
much.
week.
See ya.
Bye.
Bye.